Hello everyone, my name is Nandini Patavri and I'm from Symbiosis Institute of Technology in AIML Department A3 batch. And I welcome you for my analysis of energy consumption and related factors in the steel industry. So today we'll be exploring the insights which I have made through the Power BI dashboard and delve into the topics like reactive power, carbon emissions, and more. But we have some 5 questions which will help us to analyze the data set we are analyzing today. You can get this data set in the description. So question number 1 is to analyze the trends in the industry for the energy consumption over the time. So for this, what I've done is I have divided the column of date into 3 subsets of monthly, daily basis, and weekly basis. So according to the monthly basis, you can see in the first plot how the consumption of energy is fluctuating with the January, February, with the January to be the highest and February to be the lowest. We can see there are 7 months approx which have the highest consumption of energy in the year, and February is the lowest month for the energy consumption. Moving on to the second subset, which is for the weekly basis, as we can see here, there's a slight increase on the Monday, which shows us that there's highest energy consumption on the Monday rather than and an equal energy consumption on the other days, that is from Tuesday to Friday. Moving on to the daily basis, we can see that there are 30 days in a month, and according to it, there was an equal energy consumption on each of the day. Just on the weekends, that is just on the last days of the month, it was less energy consumption. So this was the analysis and the plots I have shown you. These are the 3 plots, as you can see here, for the first question, which we were analyzing for the energy consumption, that is for over the time. And as you can see, I divided into the 3 parts to make it more clear and helpful to understand the analysis. Moving on to the second question, that is to explore the relationship between the energy consumption and the reactive power for both leading current and the lagging current. For that, first I would like to tell you that I have actually taken the sum of the both the columns in the data set of lagging current and the leading current. This will help us to get a total value and get an easy analysis with compared to the energy consumption. This will help us make more prominent conclusions in the end rather than waiting in the data set. So taking sum will help us, and hence, as we can see that light blue color shows the sum of leading current of reactive power, and the dark blue current shows the lagging current reactive power. So we can conclude here that for a particular consumption of energy, the sum of leading current is more than the sum of lagging current. Similarly, there's the third part of our question, which asks us about to explore the relationship between the power factor on the basis of energy consumption. So we don't have any different graph for the same. In this question, we have done very similar to what we have done in the previous question. That we have a separate columns for the power factor of leading current and the lagging current. So we have first taken the sum of the columns, which will help us, as I said, for the analysis to compare it, as it is easy to compare the total value with the consumption of energy rather than taking all the values over the time. So as we are done with the summing it up, we can see that we have used stacked bar chart in both the questions. So the here same light blue color shows us the sum of leading current power factor, and dark blue color shows us the sum of lagging current power factor. And similarly, for the same consumption of energy, we can see that the sum of leading current power factor is more than the sum of lagging current power factor. So these actually, you see, these questions will give us deep analysis in the steel industry for the next steps that should be taken to, to lessen the energy consumption and to make it more sustainable. Moving on to the fourth question of our analysis that covers that asks us to investigate the variability of the carbon dioxide levels with both the load levels and with the energy consumption. So for this question also, we have plotted two graphs, which is first a pie chart, which shows the count of CO2, that is the CO2 emissions on the basis of the load levels, load type. And the second is the here, as you can see, my pointer is with the consumption of the energy. Talking first about the load type, as we can see, the carbon emissions increased with the light load. As you can see, the gray color showed the light load, dark blue color shows the medium load, and the light green color shows the maximum load. So talking about the light load, we can see that the count of CO2 increased with the light load, that is by 51%. Similarly, if we talk about the second part of the question, that is how is the count of CO2 affected by the usage of the energy consumption, then we can see the graph, the graph that the plot that we have plotted shows a lot of fluctuation, which really don't tells us a very effective answer or conclusion of how the count is increasing. But still, we can say that as the consumption of energy increases, the carbon emission is increasing. As I have here to get this plot, I have sorted the axis. The x-axis is sorted in the descending order, and similarly the y-axis, so that we can the axis is sorted in descending order to get the actual fluctuations in the graph. So as you can see that there are some emissions of carbon when there is high consumption of energy. So this was our fourth question, which we saw for the carbon emissions. Moving on to the fifth question, is about to investigate, to actually compare the energy consumptions between weekdays and weekends. Now, this is an again insightful question to understand about the energy consumption in steel industry, whether it is more on weekdays or weekends. So again, we have used a pie chart here to depict it how much the energy consumption is on weekdays and on weekends. As you can see that we have used light blue color to show weekend and dark green color to show weekdays. It is clearly depicting that the energy consumption was very much high on weekdays rather than on weekends. And this can be also proved by this plot, where is my pointer, that Monday had the highest energy consumption of 5,088 kilowatt hours. So therefore, we can conclude that these are some plots which gives us helpful analysis of how the energy consumption is working in the steel industry. And I hope that you get the very useful insights from this about how to, make your Power BI dashboard look like, and how you can use a data set to, and how you can use Power BI dashboard to depict any big data set and get useful insights. Summing up, we have as I said that I've given you data set in the description. You can refer that for getting a more clear understanding of my plots. Thank you for watching my video.